Gears are used for several reasons. They serve to keep the turning or rotation of two axes together. Gears can increase or decrease the speed of rotation and can easily be used to reverse the direction of rotation. Another reason gears are essential is that they transmit rotational motion to a different axis. There are many types of gears such as spur gears, helical gears, bevel gears, worm gears, gear rack. These can be broadly classified by looking at the positions of axes such as parallel shafts, intersecting shafts and non-intersecting shafts. Number 1. Spur gear. Gears having cylindrical pitch surfaces are called cylindrical gears. Spur gears belong to the parallel shaft gear group and are cylindrical gears with a tooth line which is straight and parallel to the shaft. Spur gears are the most widely used gears that can achieve high accuracy with relatively easy production processes. They have the characteristic of having no load in the axial direction, thrust load. The larger of the meshing pair is called the gear and smaller is called the pinion. Spur gears can be used to increase or decrease the torque, or power, of a given object. Spur gears are used to this effect in washing machines, blenders, clothes dryers, construction equipment, fuel pumps and mills. Number 2. Helical gear. Helical gears are used with parallel shafts similar to spur gears and are cylindrical gears with winding tooth lines. They have better teeth meshing than spur gears and have superior quietness and can transmit higher loads, making them suitable for high-speed applications. When using helical gears, they create thrust force in the axial direction, necessitating the use of thrust bearings. Helical gears come with right hand and left hand twist requiring opposite hand gears for meshing pair. Number 3. Rack and pinion. A rack and pinion is a type of linear actuator that comprises a circular gear, the pinion, engaging a linear gear, the rack, which operate to translate rotational motion into linear motion. Driving the pinion into rotation causes the rack to be driven linearly. Driving the rack linearly will cause the pinion to be driven into rotation. For example, in a rack railway, the rotation of a pinion mounted on a locomotive or a railroad car engages a rack placed between the rails and helps to move the train up a steep gradient. A rack and pinion is commonly found in the steering mechanism of cars or other wheeled, steered vehicles. Rack and pinion provides less mechanical advantage than other mechanisms such as recirculating ball, but less backlash and greater feedback, or steering feel. The mechanism may be power-assisted, usually by hydraulic or electrical means. Bevel gear. Bevel gears are gears where the axes of the two shafts intersect and the tooth-bearing faces of the gears themselves are conically shaped. Bevel gears are most often mounted on shafts that are 90 degrees apart, but can be designed to work at other angles as well. The bevel gear has many diverse applications such as locomotives, marine applications, automobiles, printing presses, cooling towers, power plants, steel plants, railway track inspection machines. Bevel gears are used in differential drives, which can transmit power to two axles spinning at different speeds, such as those on a cornering automobile. Bevel gears are used as the main mechanism for a hand drill. As the handle of the drill is turned in a vertical direction, the bevel gears change the rotation of the chuck to a horizontal rotation. The bevel gears in a hand drill have the added advantage of increasing the speed of rotation of the chuck, and this makes it possible to drill a range of materials. Worm drive. A worm drive is a gear arrangement in which a worm, which is a gear in the form of a screw, meshes with a worm gear, which is similar in appearance to a spur gear. The two elements are also called the worm screw and worm wheel. The terminology is often confused by imprecise use of the term worm gear to refer to the worm gear, or the worm drive as a unit. Like other gear arrangements, a worm drive can reduce rotational speed or transmit higher torque. A worm is an example of a screw, one of the 6 simple machines. One of the major advantages of worm gear drive units are that they can transfer motion in 90 degrees. Worm drives are used in presses, rolling mills, conveying engineering, mining industry machines, on-runners, and worm drive saws. In addition, milling heads and rotary tables are positioned using high-precision duplex worm drives with adjustable backlash. Worm gears are used on many lift, elevator and escalator drive applications due to their compact size and the non-reversibility of the gear.